Hey guys, Travis Gillespie here. We've been solving systems of equations using the substitution method. Now we're going to take a look at another problem, but we're going to use a new method. We're going to use something known as the elimination method. So the elimination method, it's actually my favorite method to use. But in order for it to work out, you need to line up or align the like terms in both equations. And then you're going to need to choose one of the variables in both equations that you want to get rid of. So either the x variable in both equations or the y variable in both equations. Once you've decided on which variable you're going to get rid of, you want to make them additive inverses. So I'm going to move this information over just a little bit. It looks like I might be able to eliminate the x variables in both equations. But take a look here. If I were to take -5 and subtract 5, I wouldn't get 0. I wouldn't bottom out at 0. I'd get -10. So I need to make these variables, or the coefficients, additive inverses of one another. So I'm going to do a couple things here. I'm going to make a line. Then I'm going to put parentheses around this bottom equation. And I'm going to change the sign of every value in this equation below. So in order to do that, I need to multiply straight through by a -1. So I'm going to rewrite this equation that's on top down below. I have -5x plus 7y is equal to 11. And now I'm going to rewrite my new equation below that. Well, two negatives make a positive. So I have positive 5x here. So I'm pretty much going to add the opposite of each term in this second equation here. So I have positive 5x. Now a negative times a positive, I'm going to get a negative, so I'm just going to bring that negative sign down, or think of it as a subtraction symbol, and minus 3y. It's equal to -19. Now that these variables are additive inverses of one another, they'll cancel out or eliminate each other. You're left with 0 or nothing. So I'm just going to cross them off, and I'm going to add positive 7 plus -3. Or you could think about it as 7 minus 3, which will get you 4. So you have 4y is equal to 11 take away 19, which is -8. From here, I'm going to divide both sides by 4. Now -8 divided by 4 will get me -2. So y, it's equal to -2. All right, so I'm going to take -2 and I'm going to substitute it into one of my y variables of my original equations. You can choose which one you want to use. I'm going to choose this bottom one, but I'm going to just draw an arrow up here just to indicate that this is where I'm going to start my next step. So I have -5x plus 3 times, and I'm going to change pen colors real quick, -2. And I'm going to fix these parentheses here, which is equal to 19. All right, so 3 times -2, that will give me -6. All right, so I'm going to bring everything else down. I want to put parentheses around this -6. So I have -5x plus -6 is equal to 19. All right, so let's just think about this next step real quick. How can I get -6 over to the other side? Because there's an addition symbol to the left of it. Well, remember when we were combining like terms, we would circle the term and the operation to the left. So the operation to the left is addition. I'm going to do the opposite of addition, which is subtraction, but I'm going to subtract -6. Two negatives make a positive, so you can think about that as, you might call it slash and dash, or you might call it double dash. Either way, you're going to add 6 to both sides of the equation. All right, so now I have -5x is equal to 19 plus 6, which is 25. I'm going to divide both sides by -5. So negative 5 and negative 5. I'm left with x is equal to 25 divided by negative 5. Well, that gives me negative 5. All right, so my solution is negative 5 for my x value and negative 2 for y. And I'm going to box this information up.